Okay, Trig, this is the second half or part B of section 12.3. We, in the last video, talked about adding, subtracting, and then scalar multiplication, and now we're talking about regular multiplication. So when you're adding and subtracting, the two matrices you need to make sure that they are exactly the same size. Scalar multiplication doesn't really matter what size the matrix is, but for matrix multiplication, when you're multiplying two matrices together, remember that the middle dimension has to be the same. And the reason for that is when you are doing the row times the column, you really need to make sure that it has the same number of elements, okay? So, that's kind of the way that works. If it doesn't have the same number of elements, then, you can't do it, and there's going to be no solution. So we ended up doing AB, A times B yesterday or in the last video. Now they want us to do B times A. Now sometimes it will work, sometimes it won't work when you do B times A. Let's see if this one ends up being one that works out. So before I write it all out, let's see. B is a 3 by 2. And A is a 2 by 3. So this one will work, right? The middle two, or the middle dimension here, the twos are the same, okay? And now it's important to know that like AB will not end up having the same solution as what BA will, okay? Normally when you do just like, arithmetic or whatever, like just taking 2 times 3 and 3 times 2, you're going to end up with the same solution. Both of them end up being 6, but for matrices, it is not the same, okay? And in fact, for this one, when we took A times B, we got a 2 by 2 matrix. Here, we're going to get a 3 by 3 matrix because you cross out the middle two pieces, so this one's going to be a 3 by 3 when we end up with it, okay? So I'm going to write out my matrices here. So B was 2, 0, 1, and negative 3, 5, 8. So that's what he is, and we're multiplying him by 3, 1, 2, negative 1, 0, 4. That's what he's going to look like, okay? And we need a 3 by 3 matrix, so I'm going to go ahead and write him out here. 1, 2, 3, 1, 2, 3, 1, 2, 3. That's what he's going to look like. All right, so we need those 3 spots. All right, so when we get started here, this guy is in row 1, column 1. So he's like 1, 1, 1, okay? So I need to take row 1 here times column 1 here. Okay, so that's what he's going to look like. So row 1 times column 1, okay? And I can do some scratch work off to the side over here if I need to. So 2, negative 3, and 3, negative 1. So to start with, I multiply by 2 times, I take this 2 times this 3, 2 times 3, and negative 1, negative 3 times negative 1. And I add those together. So this is going to give me 6, this is going to give me positive 3, so here will be 9 when I add those together, okay? This second guy is row 1, column 2. So I need to take row 1 here times column 2 here. Okay, so same row that I'm dealing with, but a different column. So here is 2 times 1 plus negative 3 times 0 in this case. Okay, 2 times 1, negative 3 times 0. It's like laying this guy on top of that one. Okay, 2 times 1 is 2, negative 3 times 0 is 0, so I'll just have 2 there. Okay, the last one, this one is row 1, column 3. So I'm going to take row 1 times column 3. So the first thing I do is 2 times 2. I'm going to add that to negative 3 times 4, okay? So 2 times 2 is 4, negative 3 times 4 is negative 12, so I have 4 and negative 12, which is negative 8. And there he is, okay? All right, so I'm going to go a little bit faster in this next one, or this next row. This guy right here is row 2, column 1. So I'm really kind of done with this guy, so if you want to cross him out, you can do that. Now I'm going to do 0, 5 times everything. So 0, 5 times this first, 0, 5 times the second row, 0, 5 times the third row, and that's going to give me those 3 places. Okay, so let's see. I'm going to try to do this without writing it all out because I have a 0 in there. It's going to make everything really nice. So 0 times 3 is going to just be 0, but 5 times negative 1 is going to give me negative 5. Okay, 0 times 1 is nothing. 5 times 0 is nothing. So I have 0 there. Okay. 0 times 2 is nothing. 5 times 4 is 20. Okay, so I have that going across there. All right, so now he is done. Okay, this last one, this is row 3, column 1. So I have row 3 times column 1. There he is. So now I'm going to do 1 times 3, which is 3, and 8 times -1, which is -8. So 3 and a -8 makes -5 when I add them together. Okay, this is row 3, column 2. So row 3, column 2. 1 times 1 is 1, and then 8 times 0 is just 0, so I just have that 1 times 1. And then the last one, this is row 3, column 3, so I have 1, 8, and 2, 4. So 1 times 2 is 2. 8 times 4 is 32, so I have 2 plus 32 is 34. Okay? The more you do this, the faster you get at it. And so, but again, just like adding and subtracting, there's a lot of room for mistakes. So, and just again, AB is not going to be the same thing as BA. This is my AB matrix. This is my BA matrix. They're not even the same size. Okay. So just be careful with your algebra. If you need to write it out every time, go ahead and do that. That is A-okay. All right. Now, they've got 2 more that they want us to multiply together. So the first one is A times C. Okay. C, we haven't determined what C is. C is a 2 by 2 matrix. Okay, so they want us to take A times C. A is a 2 by 3. C is a 2 by 2. Okay, so this is what I have going on here. I have a 2 by 3 times a 2 by 2. And I look at those middle 2 pieces, and those have to be the same number, and they are not. So this one, that's kind of nice. I don't even have to do any work because there's no solution to that. Okay, so when the 2 middle dimensions are not the same, then I'm not going to be able to multiply my rows and my columns. One of them is going to have more than the other one. Okay, then this one, C times A. So if I do them in the reverse order, this would be a 2 by 2 times a 2 by 3. So I can take C times A because I have those 2 middle pieces, and what will end up happening is he will end up being a 2 by 3. Okay, so let's write out. I'm gonna recopy from up above. C is 1, 0, 3, -1, and A is going to be 3, 1, 2, -1, 0, 4. There we go. Okay, so he's going to end up being a 2 by 3 matrix. So he's going to really look like what A is. 1, 2, 3, 1, 2, 3. You don't have to put those blanks in there, but I always do just so that I know. It kind of helps me track where I'm at. Okay, so this is row 1, column 1. So row 1, column 1. Okay. All right. If you need to write this out, go for it. 1 times 3 is what I do first. 1 times 3 is 3, and 3 times -1 is -3. So I have a positive 3 and a -3 that I'm adding together, and that is 0. Okay. Then I do, this is row 1, column 2. So I do row 1 times column 2. Okay, 1 times 1 is 1, 3 times 0 is 0, so I have 1 plus 0, which is just 1. Okay, row 1, column 3. Row 1 times column 3. So 1 times 2 is 2, 3 times 4 is 12, so I have 2 plus 12 is 14. Again, if you need to write it out, go ahead and write it out. Okay. All right, now I'm really kind of done with this 1, 3, that across the top. Then I'm going to start with 0, 1. So this guy, this cell right here is the second row, first column. So I take my second row here times my first column here. 0 times 3 is 0. -1 times -1 is positive 1. So I should just have a positive 1. Okay. Row 1, column 2. I have 0 times 1 is 0. -1 times 0 is 0. So this is going to be 0. Row 1, column 3. So 0 times 2 is 0. -1 times 4 is -4. So that's what my matrix will look like for CA. There he is. Okay. All right. Now, how does this transfer into like story problem stuff? A furniture restorer refinishes chairs, tables, and dressers. So they have kind of a matrix here for chairs, tables, and dressers. The amount of time required to complete each step of refinishing and the cost per hour of each step are given by the following matrices. So this is kind of how this works. Chair, this is all the work that's put into doing the chair, all the way straight across here. And the work is categorized into 3 categories. So to remove the finish, it takes a ½ hour for the chair. To sand it, it takes 2½ hours. And then to finish it again, so probably putting the varnish and all that good stuff on again, takes another hour, okay? So that's for the chair, and then the table is categorized like that as well. Dressers categorized like that as well, okay? And then the cost per hour for removing, finishing, for sanding, and for finishing is each one of those, okay? So evidently sanding is the most probably laborious task because it is the most expensive. So what we can see here is when we're multiplying these, this is a 3x1 matrix, okay? And this is, a 3x3 matrix. This guy is a 3x1 matrix, 3 rows, one column, okay? So when I would multiply these together, what I'm going to do is I'm going to multiply this row by this column, okay? And you can kind of see how this is transferring. Removing finish is this 0.5 or this half hour. I'm going to multiply that by the removing finish rate, which is over here, which is 7, okay? Sanding, 2.5 hours, that's going to be the rate of $18, okay? And then finishing, 1 hour is going to be the rate of $10. So I'm multiplying each one by their own category, okay? And so when I multiply these together, the middle two dimensions are the same, so I know that I can multiply them together. But my answer is going to be a 3x1 matrix, okay, because that's what's left over. So I have a 3x1 matrix, okay? So I have 1, 2, 3 right here. And what's going to happen is when I'm multiplying those together, what's going to be left over is going to give me the total cost of the chair, the total cost of the table, and the total cost of the dresser, okay? Because kind of like when I have the threes in the middle, like those dimensions cancel out. So the removing finish cancels with the removing finish, the sanding cancels with the sanding, the finishing cancels with the finishing. So all I have is each item times the cost, okay, of each item. So I have 3 items, and then I have the cost of each item, okay? So that's what's going to be reflected down here, okay? So when I'm doing this, I'm gonna go ahead and multiply. So this is row 1, column 1. Okay, so I'm going to take row 1 times column 1 here. There's only one column. Okay, so I do 0.5 times 7. So that's going to be like a half times 7, or 3.5. I'm going to add that to 2.5 times 7. So 2 times 7 would be 14, and half of 7 is 3.5. So 14 plus 3.5 is 17.5. If you need to use a calculator, go for it. 1 times 7. Oh my gosh, what am I doing? What am I doing? Not right, not right, not right. Let me just write this all out. I'm going to do 0.5 times 7. Blah. Let's do this. I want to take 2.5, not times 7, times 18. There we go. And 1 times 10. That's what he's going to look like. So let me write this out so I don't get confused. Half of 7 is 3.5. 2.5 of 18 is 36, plus 9 is 45. Let me check that with a calculator before I say for sure. 3.5 times 18, 45. Plus 1 times 10 is 10. So I have 3.5 plus 45 plus 10 is going to be 58.50. So I can see that the chair is going to cost me $58.50. Okay, so that's what that one was, $58.50. Okay, next one, I'm going to do the second row times the first column. So I have 1 times 7 plus 4 times 18 plus 1.5 times 10. Okay, 1 times 7 is 7. 4 times 18 is 36 doubled, 72 maybe? 72. And 1.5 times 10, don't use a calculator for that, move the decimal 15. So 72 plus 7 plus 15, that's a total of $94. $94 for the table, okay? And then the last one is the third row, the third column, or first column, third row, first column, so 3 times 7 plus 7 times 18 plus 4.5 times 10. Okay, 3 times 7 is 21. I don't know. I'm not even going to try. 7 times 18. 126. And 4.5 times 10 is 45. So plus 21 plus 45 is $192. So $192 is how much it's going to cost to do the dresser. So this is just kind of an application problem of when you would use those matrices together. It's kind of an easy way of figuring up each one of those and how much they would cost. So there you go.